Hey there, Charger fam. It's Miss Boyd here. Today we're talking about ratios and proportions. This is a lot of stuff that we've had before in previous classes, so I'm hoping you can reach back to that info and make it applicable here for geometry. So first, the definition. What is a ratio? A ratio is a comparison of two values, A to B, often expressed as A to B, where we put a colon in the place of the word to, or as a fraction. All right, so we're used to fractions. And we know kind of how those work, I hope, knock on wood. We're going to apply that here today. Excuse me. A proportion is an equation stating two ratios are equal. So the four fractions you see down here in the box below are all proportions because it says this ratio is equal to this ratio. And as it says above, there are four strategies that we're going to use for solving these. One is the cross products, where we multiply the top with the bottom of the opposite fraction, and the same thing again to make an x. So we'll end up with 12 times x equals 10 times 3, not 30. So we can simplify and we get 12x equals 30. We divide both sides by 12 to get x alone, and x is 30 over 12. We can simplify that and divide everything by 6 and get 5 over 2 for our value for x. We can also use the common multiplier method. We can see here that we can multiply this denominator by a number to get 12. 3 times what is 12? Well, it's 4. So that means we can multiply the top by the same thing and get the same answer. So the two bottoms are the same. The two bottoms are 12, so we don't care about that. What we do care about is now we have 4x equals 10. We divide both sides by 4, and we get x is 10 over 4, or 5 over 2. Next, we can simplify fractions. I know that by looking at 10 over 2, these are both even numbers, so I can simplify that. I can divide everything by 2, and that becomes 5 over 6. So if I want to get from 3 to 6, I have to multiply 3 by 2. That means I multiply x by 2 as well and get 2x equals 5. I can divide and get 5 halves like we've gotten all the other times before. Last method, I'm not even going to talk about because I don't want you to use it. F to D means fraction to decimal. There's lots of ways to get errors doing that, and you won't always have a calculator to be able to do this. So I want you to know how to do it without a calculator handy. Any of these four methods, really any of the three methods up here, are ones that you could use to solve any of these problems. So let's solve one together, and then you're going to be on your own. I'm going to cross multiply pretty much exclusively because when we get down here to these kinds of questions where our ratios have expressions in the numerator or denominator, we can't really simplify that. It just makes everything exponentially harder. So we're going to stick with cross multiplication. If one of the above methods makes more sense to you, please feel free and use that. So when I cross multiply, You don't have to make the circles, but they sometimes help me to see what I need to do. I've got 8.1x equals 6 times 3.4. I want you to notice something really quickly. I went from having a fraction here and a fraction here split by an equal sign to no fractions, and an equal sign. So a common mistake that many people make was when they do the cross multiplication, you would write 8.1x divided by 6 times 3.4. That's not it. We have to put this equals in here. That's what makes it cross multiplication. So you go from all sorts of fractions to not one fraction. So let's multiply. 8.1x is going to equal 20.4, I believe, if my math's right. I can divide both sides by 8.1 to get x alone. And I get x is about 2.52. You know how I feel about decimals. When you have decimals in the fractions, just go ahead and leave them as decimals. We'll do this first row together, and then you're going to work on your own. Now we have 4. If we're multiplying, when we cross multiply, and we've got a number here, a constant, and an expression here on the top, we're going to leave the expression in parentheses so that we can remember to cross multiply. 3 times 5 is 15. Or we can remember to distribute was the word I was going to say. So we distribute the 4. We get 4x plus 4 is 15. To subtract that 4 from each side, and I've got 4x equals 11. Divide by 4, and x is 11/4. One more. Cross multiply here. We get 5.5x times x plus 2 equals, and then another expression times a constant, 4 times x plus 3. Double distribute here. 5.5x plus 11 is 4x plus 12. Let's subtract that 11 from each side, and we get 5.5x is 4x plus 1. Subtract our 4x from each side, and we get 1.5x equals 1. And that means x is 0.67 or so. All right, now you're on your own. Try this first one all by your lonesome. Okay, we're going to cross multiply. And we've got 5x times 4.7 equals 12. I'm going to multiply these together on the left. I get 23.5x is 12. Divide by 23.5. I get x is around 0.51. Try the next one. Cross multiply and I get 21 equals 8 times x minus 3. Well, it's 21 equals 8x minus 24. I'm going to add my 24 to each side. And that's 45 equals 8x. Divide by 8. And we get x equals 45 over 8. I don't think I can simplify that. Last one. Go and do it. All right. Got 5 times x plus 1 equals 2 times x minus 4. We distribute. 5x plus 5 is 2x minus 8. Let's add 8. 5x plus 13 is 2x. Subtract 5x. And that's 13 equals negative 3x. Divide. And x is negative 13 over 3. My handwriting is the worst. You're welcome. 3 more. Get to the first one. I've got negative 8x equals 2 times 2x plus 3. That's a negative 8x equals 4x plus 6. I'm going to subtract my 4x from each side. That's negative 12x equals 6. Divide by negative 12, and x is negative 1/2. Next one's yours. All right, 5 times 3x is 15x. And that equals negative 8 times 4x minus 2. Distribute negative 32x plus 16. Let's add this 32x to each side. That's 47x is 16. Divide both sides by 47, and x is 16 over 47. Last one, make it happen. All right, we've got x times x. Ooh, we're really reaching back into the algebra brains here. That gives us x squared. And that equals 4 times x minus 1. We distribute and get 4x minus 4. Subtract 4x from each side. And we're going to add 4 to each side and get everything on the same side. From here, you would need to factor. I'm not going to ask you to do that because it's kind of outside of the scope of what we're doing. But if you were to do it, you'd get x minus 2 times x minus 2. And that means your answer is x equals 2. All right, let's flip your paper over. Maybe if you can get mine to work or yours to work better than mine currently is. There we go. And talk about extended ratios. An extended ratio is a comparison of more than 2 values, A to B to C, which includes the ratios of A to B, B to C, and A to C. You'll see what I mean here in just a moment. This is mostly applicable to triangles. In triangle ABC, this is triangle ABC. The extended ratio of the angles is 3, 4, 5. Find the measure of each angle. Well, what do we know about triangles? We know that when we add the angles up, the sum of the angles, we get 180. And if the ratios between these angles is 3, 4, 5, that means I can describe them as 3x, 4x, 5x. So I know if I add these angles up, 3x plus 4x plus 5x, I get 180. Well, now I have one variable and one equation, and I can solve. I add all the x's together, and I get 12x equals 180. Can divide everything by 12, and I get x is 15. So now I can determine what all of the angle measures are. Angle A, 3x, is 3 times 15, and that's 45. Angle B is 4 times 15, and that's 60. Angle C is 5 times 15, and that's 75. To check this, all you have to do is add those angles back up, and you should get 180. So these extended ratios are super helpful, like I said, when we're looking at triangles. Let's do some more. In triangle DEF, the ratio of the angles is 5, 12, 13. Find the measure of each angle. Well, like we just did, we give each of those an x. And we add them up to get 180. Now we solve for x. 5 plus 12 is 17, plus 13 is 30x equals 180. We divide, that means x is 60. Oh, not 60, just kidding, just 6. So we have to plug that into our angles. So we have 5 times 6 is 30. 12 times 6 is 72. And 13 times 6 is 78. So those are our angle measures. Next one's for you to try. Give it a swing and we'll check your answers. Triangle GHI, the ratio of the sides is 2, 3, 4 with a perimeter of 144. Find the measure of each side. Oh, this one's just a little bit different. Sorry about that. The perimeter of the triangle, we add all the sides together. So we give them each 2x plus 3x plus 4x. We add them up, and this time we get 144. Add up the x's on the left. That's 9x equals 144. Divide both sides by 9. I get x is 16. Now I can plug it in. 2 times 16 is 32. 3 times 16 is 48. And 4 times 16 is 64. So those are the lengths of each side of the triangle. The next one's for you. Go ahead and try it out. Okay, we've got triangle JKL. The ratio of the sides is 455 with a perimeter of 217. So we've got 4x plus 5x plus 5x is 217. That's 14x is 217. If I divide by 14, I get x is decimal 15 and a half. We plug that in. 4 times 15 and a half, we get 62. And then 5 times 15 and a half is 77.5. And we have that length twice. Last one, we can do this one together. It's a little bit different. In parallelogram, MNOP, the ratio of the angles is 4, 5, 4, 5. Find the measure of each angle. So we know that the interior angles of our parallelogram are going to add up because it looks like this. It's going to add up to 360. So we have 4x plus 5x plus 4x plus 5x is 360. Combine like terms, and we get 18x is 360. Divide by 18, that gives us x is 20. We plug these in, we get 4 times 20 is 80 twice, and 5 times 20 is 100 twice. I hope these are pretty straightforward for you, as they are for me. If you have any questions, feel free and let me know, and I'll talk to you soon.